Hi everyone, welcome back. Today we are diving into Health Connect, Google's health data platform for Android developers. Let's see what it is, how it works, and how you can build apps with it. Before we dive into the app's code, let's look at the Android manifest, the app's blueprint that tells Android what our app is, what it shows, and what it needs. First is manifest plus namespace, which is shown in the top 5 lines. Up top, we declare XML header and the manifest tag. The XML Android and manifest tools namespace let us use Android and tools attributes throughout this file. The second block is the application. This single line application tag configures global app behavior and visuals. Android allow backup equals true. Enables OS backup, restore for app data. Android data extraction rules and Android full backup content points to XML rules that controls what's included and excluded during the backups. Android icon and Android round icons set the launcher icons. Android label is the name shown to the users. Android support RTL equals true enables right to left layout mirroring. Android theme @style theme.finished version applies our app wide theme. Third thing is Health Connect package visibility, which is shown under the queries block. Android limits which installs package your app can see unless you declare them. The Queries section let our app check whether Health Connect is installed by listing its package name, which is com.google.android.apps.healthdata. This is important because our app may want to detect availability and guide the user to install or update Health Connect if needed. Third, what's not here yet in the screenshot is the closing of manifest. Notice we haven't declared any activity yet. In a typical project, we will add our main activity here and give it a launcher so Android knows which screen to open first. We also haven't listed any dangerous permissions here for Health Connect. We will request permissions at the runtime. So the manifest sets up our app's identity, backup behavior, visuals, theme, and package visibility for Health Connect. Next, we will see and add main activity. This file is where we will register it as the launcher entry point. Now let's look at our main activity. This is the entry point of our app, meaning it's the first screen Android launches when the user opens the application. First is app declaration. At the top, we see package com.example.finished version. This defines the unique namespace of our app. It helps Android identity of our application separately from all others on the device. Then comes the imports. We import two key libraries. App Compact Activity, which gives us access to the modern Android features while keeping backward compatibility with other devices. Bundle, which is used to pass and save data when activity are created or restored. Then is the class definition, which shows class main activity, app compact activity. Here we define our main activity class. Notice that it extends or inherits from app compact activity. That means it's type of activity which in Android terms is just one screen of the app. OnCreate method shows inside method. Inside we override the onCreate method. This method runs as soon as the activity is created. Think of it as a starting point for setting up this screen. The line super on create saved instant state calls the parent class that set up code so activity can function properly. Then we call set content view r.layout.activity underscore main. This links our code to the XML layout file that defines the user interface for the screen. Now comes the build.gradle. In this part, we will look for the script for the application module. This file controls SDK versions, packaging details, and all the libraries our app depends on. Plugin blocks. At the top, we apply two plugins using Gradle version catalog aliases. The Android application plugins and the Kotlin Android plugins. This enables Android features and Kotlin support in this module. Then alias lives plugins Android application activates the Android application build logic. And the alias libraries plugin Kotlin Android enables Kotlin for Android. Then comes the Android block. This big Android block is where we configure the Android specific settings for the application. Namespace, the package namespace used for your applications. Generated resources and code com.example.finished version. Compile SDK. The Android API label you compile against newer values let you use newer APIs at the compile time. Default config. Inside default config, we define the application's identity and minimum requirements. Application ID is the unique ID on the Play Store and device. Here, com.example.finished version. Minimum SDK equals 24, which is your application runs on Android 7.0 API 24 and above only. Target SDK is 36, so you are opting into behavior changes up to the API 36. Always keep this current when possible. Versioning. Version code equals 1 and version name equals 1.0 are what you increment for releases. Instrumentation test. Test instrumentation runner points to the Android X test runner used for UI testing. Build type. For release builds, is minify enabled equals false means code shrinking. Obfuscation is off. You can turn it on later for smaller APKs and bit of complexity protection. This ProGuard files line points to default and custom rules. Java and Kotlin options. Here we can set Java 11 compatibility and Kotlin's JVM target to 11. This ensures both Java and Kotlin compiles to the same bytecode level. Then is the dependency. Dependency uses the version catalog via libraries. Aliases keeping version centralized in Gradle libraries.version.2ml. Core libraries are Android X Core, Core KTX, and Android X App Compact, and com.google.android material. Testing JUnits for unit test and Android X test.ext JUnit plus Espresso Core for Android UI test. Now, thanks for watching this video. This was a basic video about how Health Connect works and have explained three main files in the Health Connect. We set up the manifest including package visibility for Health Connect and the Android 12 requirement to set Android exported on our launcher activity. We walk through main activity, which ties our Kotlin logic to the UI. And we reviewed the Gradle setup, SDK versions, versioning, and dependency. If you are building along, your next steps are simpler. Add the Health Connect client dependency. Request permission in the code. Write a small sample record and read it back to the screen. If this helped, don't forget to like and subscribe me. In the comment section, I have given you a GitHub link in which you can see the tutorial for the same, and you can download the code for the same as well. Thank you for watching.